Mr. Bainey, and we're going to take a look at, hey, what's up, Math 1? We're going to take, hello, this is Mr. Bainey. Let's take a look at lesson 20.2, ASA, Triangle Congruence, and we're going to be looking at how do we prove triangles are congruent using this theorem. And we'll be seeing theorems in the following lessons as well. In the last lesson, we looked at Cpctc, which is one way, it's actually our only way so far that we know how to show triangles are congruent. Remember that the definition of triangle congruence is that if two triangles are congruent, all the 6 parts of one triangle are congruent to the 6 parts in another triangle, right? We call those corresponding parts. And the converse of that, if I switch that up, that's the way we prove triangles are congruent. So if we know all 6 parts that are corresponding are congruent between two triangles, then we know the two triangles are congruent. Remember, the 6 parts are the 3 angles and the 3 sides. What's nice about this lesson and the next 4 or 5 that you'll see is that we won't need all 6 parts anymore. We only need 3 parts. As you can kind of tell by this title, ASA is going to stand for angle, side angle. And it's pretty much the parts that we'll need to conclude the triangles are congruent. It means that we need 2 angles, and then we need, this is actually 2 pairs of angles, right? We have 2 angles from one triangle is congruent to 2 angles in the other triangle. The side has to be the included side, so I'll talk more about what that actually means. Included, think about in between the 2 angles that we use, and that's why the side is, or the S is the second letter in here. It's in between the 2 A's because it has to be in between. Actually, let me show you here in this picture on this page. If you're looking at the sides of, the angles of point A, angle A and angle B, the included side would be the side AB, this side right here. So AB is included between angle A and angle B. And again, that's what we mean by included. On page 1003 is the statement of the ASA triangle congruence theorem. So it pretty much just states that if we have the 2 pairs of angles and one included side, those 3 corresponding parts between 2 triangles, if they're congruent, then the triangles are congruent. So what you're going to see in these next 5 lessons, including this one, is that the conclusion is going to say then the triangles are congruent. Remember, what does that mean if the triangles are congruent? It means that all 6 parts will now be congruent. Because we only are showing that 3 parts are congruent to get to all 6 parts are congruent, right? The rest have to be congruent if we know the 2 pairs of angles and the included side. Now let's look at the your turn on page 1004, number 5, number 6. We want to figure out, are these congruent? Now we only have one triangle congruence theorem so far, and that's the ASA. We're going to be seeing more, and we're going to be adding it to kind of our tools so that we can use any of those that we need. But so far we only have 2 ways, and that's the one from last lesson, Cpctc, and then now the ASA. All right, so let's look at what is actually congruent here. We have angle B, on number 5 here, is congruent to angle C. We have angle, let's see, it's this angle right here is a right angle. If the right one is a right angle, the left one has to be a right angle because that makes a straight line. So that's angle ADB. That's the one on the left side. or the left triangle. The other right angle is ADC. Right, those are both right angles, so they have to be congruent to each other. And then finally, we have side BD is congruent to side CD, because that's given to us. So we have our three parts. We have a pair of angles, we have another pair of angles, and then we have the included side, which means the triangles are congruent. So we can say triangle ADB congruent to triangle ADC. Remember, order of the letters is important here. And they are congruent by ASA. And remember what that means? It means that the rest have to be congruent, the other three parts. That means AB has to be congruent to AC, right? These, whoops, I should have used 2 marks there, then 3 marks here in the middle. This angle at vertex A has to be congruent to the other one, it has to be. Let's look at number 6. Go and think about that while I get our information here. So we have triangle PQR and triangle STU. We're going to figure out if they're congruent. So we only know that QR is congruent to UT, and then that angle Q is congruent to angle T. What we'll need to use here is the Triangle Sum Theorem. In order to get that angle, we subtract 180 minus the other two that we know. So 72 and 38 added together makes 110 degrees, which leaves 70 degrees left. So inside of that triangle, that last angle we don't know is 70 degrees, so it's not congruent to the 67. So 67 does not correspond to any of the other 3 angles. We only have 2 pairs of congruent parts, and that's the angle Q, angle T, and then side QR and side TU. And that's all that's given to us that's congruent. So my explanation, well, my answer actually is going to be not congruent. And a number of ways that we could actually explain this. You know, include the work that's on the picture, but also you could state that there's only 2 pairs of congruent parts. You could state that angle U does not correspond to either angle P, Q, or R. Something like that. Now let's get to the part that many find pretty difficult, which is the proofs. And I'm on page 1005. Let's look at the proof on, let's look at the one on top, just so we can do an extra one here. So we have our given angle A is congruent to angle C. I'm going to mark that in the picture since we already know that that's true. And we have angle E, not angle E, point E is the midpoint of side AC. So we don't know what's congruent quite yet unless we actually state it. Let's look at what they filled in for us. So statement number 1, angle A is congruent to angle C. That's because that's the given. Statement 2 says E is the midpoint of side AC. Looks like that's also the given. Remember that when I do these proofs, I actually put those two together in the same statement because they're the same reason. So it's okay to have them together or to have them separate. Statement 3, side AE is congruent to side CE. And I want to mark that on the picture just so you can see it visually. Those 2 parts make up the whole side AC. And in the given, it says that E is the midpoint of AC. Remember that midpoint means that it cuts the segment in half. And that creates the AE and the CE, right? Those are the 2 halves. So that means they're congruent because of the definition of midpoint, right? That's what the midpoint did for us, is it cut it in half. And I'm also going to mark on the picture statement number 4, AEB, that angle is congruent to angle CED, which is those two. They're congruent because they are vertical angles. So it would be incorrect to say definition of vertical angles because vertical angles only tells us what they look like. There's a vertical angles theorem that just states vertical angles are always congruent, and that's it. So once you know two angles are vertical angles, remember they're across from each other. When two lines intersect, we know that they're going to be congruent. That's the theorem. And statement number 5. You know what? I didn't get to mark down all the parts that I have. So statement number 1, we have a pair of angles. Statement number 4, we have another pair of angles. And statement 3, we have the included pair of sides. And that leads us to statement 5, the triangles are congruent. Triangle AEB is congruent to triangle CED by ASA. We only needed 3 parts, and now we know all 6 parts have to be congruent because the triangles are congruent. Let's look at the proof at the bottom. We're given that angle JLM is congruent to angle KML, and angle JML is congruent to angle KLM. I'll be marking this on the picture soon. But first, let's write this down. Angle JLM, angle KML, and JML, KLM. Because of the given. Mine's a little crammed in there, so totally understand if you want to put that on 2 separate lines. Let's go to mark our picture here. And what I'm going to do is I'm going to separate this. And I've done this problem before, so I kind of know what to expect. But the proof triangle JML is this triangle right here that I'm outlining in red on the picture. This triangle. And then triangle KLM is the one here that I'm outlining in blue. They overlap each other. Now there's 2 other smaller triangles. There's like this JL. There's actually no point here, but if there was, right, that would be a small triangle. This one would be a small triangle. And then there's another one like right here, kind of in the bottom in the middle. So we have several triangles here going on in this picture. That's why it's important to kind of look to your prove statement to see where we're going. And we don't have any fill in the blank here, so we're kind of going in blind. And if you know that the 2 triangles are the ones that are overlapping, I'm just going to draw them separately. So here's point J, here's M, and here's L. All right, that's the one I have in red. The one that's in blue, here's K, here's L, and here's M. I did a pretty poor job of drawing that second one, but you kind of get the idea here. We have this angle JLM and KML, those are both congruent. Then we have JML, KLM, those 2 angles are congruent as well. So we have 2 pairs of angles already. Right, we only need 1 more pair of parts. Specifically, we need a pair of sides because ASA, right, 2 pairs of angles and a pair of sides. So our pair of sides that are congruent will actually be the LM, and that's that one here in the picture. Look at why those are congruent. LM is congruent to LM. They are the same exact side. They just happen to be sharing that side between both triangles. But to be thorough here, we have to state it. And it's congruent because of the reflexive property of congruence. Now I'm okay if you just write reflexive. Not going to be too picky here. This is our pair of included sides because LM is in between the vertex L and the vertex M. Those are the 2 angles we used, and therefore the 2 triangles are congruent. Now I want to point this out because you might see this, maybe not in this lesson, but it'll definitely be in one of the lessons. once we know the two triangles are congruent, then if we need to, right, we could state JL is congruent to KM, right? Those are corresponding. And JM is congruent to KL. We also know the third pair of angles is congruent, angle J and angle K, right? They have to be congruent because of Cpctc. That statement says if two triangles are congruent, and they are, if they're congruent. We stated it right here. If they're congruent, all 6 parts, we already know 3 pairs of parts are congruent. Here's the other 3 that we didn't know before. So that's congruent by this statement. That's it all the way back to the last lesson, 20.1. Let's look at this last proof here, because you will be practicing quite a bit of proofs in this whole unit. If you'd like to go and give it a try, or at least mark down the information, just kind of see what you know from there to try to get to your proof statement, go right ahead, pause the video. I'm going to go ahead and get right into it. So statement number 1 is going to be our given. I'm going to put this in 2 separate lines because there's a lot here. So angle S, angle U are right angles. I'm going to mark that in the picture. And then we also have RV bisects. Remember, that means it cuts in half. It's going to cut SU in half. That's our given. I'm still going to combine it into statement 1. So I'm going to start statement 2 right here in this third row. Okay. So what I want you to think of is, do we have any pairs of congruent parts yet? And that means, does it say anywhere that 2 things are congruent? Right, look for this symbol. This is the congruent symbol. We don't have any congruent symbol here, so we're starting at 0. We have nothing. We do know that angle S has to be congruent to angle U. And the reason here, there's a few that you can go with. I'm not going to be that picky as long as it's logical, it makes sense. There's actually a right angles theorem that I don't expect you to memorize. If you can just say right angles are always congruent or right angles are congruent, right? That's plenty enough for me. Or you can say both angles are 90 degrees. That's also fine. Because I think from there, it's, right? It's quite obvious. If they both are 90 degrees, they're both congruent to each other. So here we have a pair of congruent angles in statement 2. Okay, we got 1 down, we got 2 more to go. Since SU was cut in half, SU is broken up into ST and TU. Those have to be congruent because it got bisected. And our reason is going to be definition of bisector. So here we have a pair of congruent sides. We want to make sure that this is the included side though. So let's get our third part. And you can even tell that our third part has to be these 2 angles in order for ST and TU to be included in between the 2 angles. And so we have to name this with 3 letters since T is kind of right at that intersection point of the 2 triangles. So that's RTS and VTU. Those 2 angles must be congruent, and it's because they are vertical angles. Okay, you got to remember how vertical angles look. Right, the reason's not going to be the definition. That showed up on that last page, because the definition just tells us what it looks like. So now that we have our pair of angles, our second pair of angles, in fact, we can confirm that ST and TU are the included side. We now have enough. We have our three parts. So our fifth and final statement, triangle RST is congruent to triangle VUT by ASA. Okay, that's going to do it for this lesson. Thanks so much for watching. Have a great day.